All right, so we have this question here that was asked in office hours, and it makes a lot of sense that students are confused by optics. Optics often causes a lot of difficulty with students because it can be kind of complex. Not only that, but I feel like sometimes there's differences in the way that this is taught in undergrad versus how the MCAT tends to test these things. So let's just take a quick look at this question that was asked. I'm generally confused about optics, specifically when is an image virtual versus real with both lenses and mirrors. It doesn't last long when I try to memorize it, so I'd love to understand how it works. Also, inverted versus upright. So, telling the difference between these is a really common problem. But I'm going to take this and I'm going to go a little bit farther. And I'm going to address a little bit, like I said, I think often the issue comes with how stuff is tested in undergrad and how often you should be approaching it for the MCAT. Now, I think a lot of times when students are dealing with MCAT stuff, or maybe more often in undergrad, they get really focused on the different scenarios, right? A converging lens, if I'm inside the focal length or outside the focal length or on the focal length, or a diverging lens in those scenarios. And a lot of times students are trying to memorize all of those different issues and try to figure out, okay, under these conditions, is my image virtual? Is it inverted? What's going on with all of those? And I do want to kind of take a moment and kind of highlight that with those questions, yes, you can do that, right? Like those ray diagrams. So let me get my writing tool here. With those ray diagrams, if you memorize all of those different scenarios, you can tell if something is, for example, virtual or real, right? Or if something is magnified or minimized, like the image was made larger or smaller, or if it was inverted or upright. You can use a ray diagram to solve all of those questions. But if they ask you what's the magnification, right, or what's the image distance, you can't actually use a ray diagram to solve that. So if they ask what is the magnification or what is the image distance, a ray diagram will not be able to solve that question. And so that becomes a little bit more problematic, right? And so we need a way to answer those questions because the MCAT can ask those questions like what's the magnification and what's the image distance. And so when that happens, all of a sudden, the ray diagrams aren't going to be a good way to solve that. So in order to solve those questions, you need to be able to use equations. That's the only way to solve these questions. However, memorizing the equations will also let you answer these questions. Is something virtual or real or magnified or minimized? And so there's really no use in memorizing all those ray diagrams. And I like to do whatever I can to try to minimize effort from students, right? If you don't have to sit down and memorize a bunch of stuff, let's try to avoid doing that because that's a lot of work. And if it's not worth it, we shouldn't do it. And so that's why I encourage all students to just forget the ray diagram stuff. Don't put a lot of time and effort into this because they will only answer some optics questions and you have to know the equations to answer those optics questions, but those equations will also answer all the questions that ray diagrams will fill. And so this is just a really long-winded way for me to say we need to focus on the equations and focus on certain scenarios. So let's talk about the equations that you need to be able to deal with when it comes to the MCAT. So there are four main equations that you're going to need to know. The first one is calculating the focal length from the radius of curvature. This second one is the relationship with focal distance, object distance, and image distance. And this second equation is probably the highest yield equation. I feel like this question or this equation is used to answer more questions than honestly probably the other three combined. And so the second equation is one you really got to know. But then there's also how to find the magnification, which is minus I over O, and then there's the one for calculating the power of a lens, which is measured in diopters. So those are the four equations that you really want to make sure you have down. But notice that doesn't really answer this question, right, about how to deal with virtual and real images and how do we find those things. So for that, we need some extra rules. And so this is where the positives and negatives come in. So images are, if they're positive, that's a real image. If it's a negative, it's a virtual image. Now I want to be clear. This is true for all types of lenses and all types of mirrors. all of these equations and all of these rules apply to every single scenario. So you don't have to worry about like, okay, when is it this or when is it that, and kind of like putting those together. So you want to get these down really well because these are going to be really critical for answering questions. Now, focal length is going to be positive for a converging system and negative for a diverging system. And magnification, if it's positive, that means it's upright. If it's negative, it's inverted. But we also have some added value here, or added layers of information with what's the absolute value of the magnification. If the absolute value is greater than 1, that means it's magnified. If it's less than 1, that means it's reduced. So if something had a magnification of -2, that would mean the thing was doubled in size because it's 2, right? But it's also going to be flipped upside down because it's negative. So the image is going to be flipped over and then magnified twofold. It'll appear twice as big as it actually is. Versus if you had something that had a magnification of 1/2, well, that's going to be shrank. So the image is going to appear half the size of the actual thing. And it's still going to be upright, though, because it's a positive magnification. Now, there is a little bit that we do need to pay attention to here with lenses and versus mirrors, because which side of a lens is real and which side of a mirror is real, that actually does change, and I know that that can cause some confusion with students. And so if we're looking at what's going on with that, right, note that the real side of a lens is the other side of a lens, right? And that should make sense. If you have an object here and you see through that, like, it should be on the other side of the lens. So if this is your object, that light should go through the lens. And so the other side of the lens is real. And it's the opposite with a mirror, right? Like if you have some object here, and let's say there's a mirror, and so like behind this is like a brick wall, but there's a mirror here. If we have an image form on the other side of a mirror, right, like there's nothing actually on the other side of that mirror. So the other side of a mirror is going to be virtual, right? If we're dealing with a mirror, the real side of the mirror is the same side that the object is on because light reflects off of that. So this is going to be the real side. But for a lens, light should go through the lens. So the other side of a lens is real. The same side, this is where we're going to have virtual things. And so that is a layer to this that we do need to pay attention to. Note that like the equations that we're dealing with and all of these rules, these apply to both lenses and mirrors in all scenarios. The only difference here is, okay, the other side of a lens is real. The other side of a mirror is virtual because light bounces off of a mirror. And so light isn't actually going to that other side. So these are the big things that we need to kind of keep down. And if you've got this, if you've got these equations, you can solve pretty much any question that the MCAT can throw at you. So let's kind of take a second here and let's look at a question. Right? So let's take a setup where there is an object 6 meters from a lens with a focal length of 2. So the MCAT isn't going to do this, but I am, because I want to make sure that we're all super prepared. Like the MCAT, like what I'm going to ask you guys is, what's the object? What's the image distance? What's the focal length? What's the magnification? Is this real or virtual? Is it upright or inverted? Is it magnified in size or is it reduced in size? To be honest, like I said, the MCAT is never going to ask you all of those things. They're going to ask you 1 or maybe 2 of those things in any given question. But if you can answer all of those things with this question, then you can answer any question that the MCAT can throw at you. So I want to reiterate here. I'm not going to draw a ray diagram because the ray diagram might only give me some of this information, and I don't need some of it. I want all of it, right? I want a way to solve all of these things. So let's go ahead and try to tackle this question, right? So first off, we know that the object distance is 6, so that's going to be 6 meters. The focal length is 2. Now, I want to ask you guys, is that a converging lens or is that a diverging lens? Which one's that going to be? Well, that's going to be a converging lens because it's a positive focal length, right? Going back to the rules that we had before, if our focal length is positive, that means it's a converging system. Note for a lens, that means a lens that is shaped like that, right? That's a converging lens, right? Versus a diverging lens is going to be kind of caved in, right? So what we're dealing with here is a converging lens. So we know our lens is going to be shaped like that. To be honest, I don't know if we don't really need that to answer any of these questions, but it is kind of nice to try to make those connections. So that's pretty much it, right? That's all we're kind of given in this question is what's the object distance and the focal length. But we can find everything else in this, on this page by just doing some calculations, right? Remember this equation that I said was probably the highest yield equation when it comes to optics? Like sometimes the MCAT makes you use this equation and another equation. Sometimes it's just this equation, but this is a pretty high yield one. And so note that we have the focal length and we have the object distance, so we can find the image distance from that. So we can just plug in, okay, 1 over the focal length is going to be 1/2, is equal to 1 over the object distance, which is 6, plus 1 over the image distance, right? So now you can subtract 1/6 from both sides, minus 1/6, and so you get 1/2 minus 1/6 is equal to 1 over I. Now we want to get a common denominator here, and so 1/2, we want to convert that to, instead of 1/2, we'll want to change that to 3/6, right? So that's 3/6. Ooh, I should have picked a word that was easier to say. Minus 1/6 is equal to 1 over I. So 3/6 minus 1/6 is going to be 2/6, which is going to be equal to 1 over I. And that also simplifies to just 1/3. I should probably stick with the lowercase I not to be confusing here. And so if we take a look at that, link back in here, so we have 1/6, or 2/6, which is equal to 1/3, right? So that's going to be 1/3 is equal to 1 over I. So if 1 over I is equal to 1/3, then that means I must be 3. And so our image distance is going to be 3. Now that's not something they gave us, but it's something we could find. Now actually we can start to answer some of those questions down below. Is this going to be a real image or a virtual one? Well, my image is a positive image distance, so that means it's going to be real, right? So because the image is positive here, that means we're dealing with a real image, which, because we're dealing with a lens, that means our image is going to be on the other side of the lens. Now, for the rest of this, we need the magnification, right? Because the magnification will tell us, 1, what the magnification is, but 2, also is it upright or inverted or magnified or reduced in size? And so we need to calculate that. That's actually not a big challenge, right? Remember that magnification is equal to minus I over O. We have our I. We have our O. Nope, that's my focal length. My O is here, right? So my magnification is going to be equal to minus 3 over 6. So that's going to be, my magnification is equal to minus 1/2, right? So minus 1/2 is going to be my magnification. So now we know that the magnification is negative, so it's going to be inverted. And we know that it's going to be reduced in size because the absolute value of our magnification is 1/2. So this image is going to be half the size of what it should look like. And so it's shrank, it's minimized, and it's going to be flipped upside down. So it's also going to be reduced in size. Now you could, like I said, you could memorize ray diagrams and go through all of that work in order to tell if something is real or inverted or reduced in size. You could memorize that scenario, but that's not going to give you the image distance or the magnification, like the actual number for magnification. And so to find those, you have to use the equations. And so you could go through all this work of memorizing the ray diagrams and you'd answer some of those questions, but to answer all of these questions, you still have to get the equations down. So like I said, this is why I really want to emphasize, don't do more work than you have to do, right? So if the equations alone will handle this, don't learn the equations and ray diagrams because it's a lot of work and it's unnecessary, right? The equations alone will do. So I hope this makes sense. Feel free to make a bunch of practice questions, right? Like plug whatever other numbers you want to plug in here, and you should be able to calculate all of these things for any different scenario that you create. I really encourage you to take some time, like I said, to memorize those different scenarios. Like, you have to get these equations down. Optics is a pretty high yield topic, so you want to get those equations down, you want to get these rules down, but after you've got those things, then you can handle literally anything that the MCAT will be able to throw at you in terms of optics.